Hey, sixth graders. So today we are going to do 511, and 511 is going to be fairly challenging but very useful. We use this a lot in science, and we use this, a lot in financing. We use it a lot, like in banks, and grocery stores, and anything that has to do with advertising. We actually use this quite a bit in the real world as adults, and it's really important that you learn this now so that when you become an adult, you are proficient in using these skills. And so today's learning objectives are we're going to investigate how the rate of motion relates to tables, graphs, and equations relating to time and distance. Time and distance is going to be really important here, and it's important that we understand the differences in how they are related. And then also use different representations to find or estimate distances traveled in given amounts of time. So let's go ahead and turn to page, what is this? I did not want to draw. Sorry. This is page 207. So if you go to 207 on your math journal, that's where we're at. Okay, so walking rates. So student 1 walks at the same rate as student, let me try that again. Student 1 walks at a constant rate of 3 feet per second. So for every 3 feet, 1 second has passed, or for every 1 second, they have walked 3 feet. Whereas student 2, maybe this student is a little taller, walks at a constant rate of 5 feet per second. Okay, so the elapsed time and the distance walked for each student vary together. So we talked about this in the last lesson, varying together. So let t be the number of seconds elapsed since a student started walking. So t for time, let's just write that. Be easier for us. So t for time, and this is going to be used for the entire lesson. And then we'll say d for distance. Whoops. Sorry. Okay. So the double number lines below show the variables t and d varying together for two students. So we have student 1 and we have student 2. And these graphs show that for every 1 second, 3 feet have been traveled. So after the next second, so second 2 or 2 seconds, it'll be 6 feet, and so on and so forth. And you can see that there's a pattern up here, right? Plus 3, plus 3, plus 3, while down here we're going plus 1, plus 1, plus 1, plus 1, right? Okay. So for student 2, same thing, different numbers. Instead of 3 feet, this student is walking 5 feet for every 1 second. So in the next second, he will or she will have walked 10 feet in 2 seconds. Okay, we can see that rate. So my question to you is, can t and d be whole numbers? Can they be fractions and decimals? What do you think? The correct answer is they can be both. They can be both fractions or decimals or whole numbers. Just going to write be both. Good. Okay, so the next concept that we really need to dial into is the difference between a dependent and an independent variable. And I want to write this over to the side, and I'm going to do this in purple marker. Let's look at the word dependent. I know you love when I do word studies. Not. I know you don't, but it is really important. Dependent. The word dependent literally means relies on something, or to rely on something. So this variable is going to depend on what happens to the other number. That doesn't even look like a G, I apologize. Okay, we're going to redo that because sloppy is bad. All right, so that's dependent. Independent, remember when we studied prefixes, a prefix is a group of words or group of letters that comes before a word, prefix. This in part, that means not. So it means literally not dependent or not reliant. It does not rely on anything. Okay? So dependent means to rely on something. Independent means not to rely on something. This is a very important concept for you to understand, not in just math. It is really important in science, especially in physics and biology and chemistry, all science, and in your language development, that is also really important. Okay, so let's look at this. It says, when two variables are related, we can often think of one as the dependent variable and the other as the independent variable. The distance each student walks depends on the elapsed time. So D is the dependent variable, whereas T is the independent variable. T, the time, does not change. It does not care about what happens to anything else. Time passes no matter what. However, the distance traveled, that changes. That is something that changes at a different constant or a different rate. So we can use the x-axis in the left column for the independent variable, and we can use the y-axis in the right column for the dependent. So if you look down here, number 2, complete each table. So I'm going to zoom up on student 1. Student 1, if we look back here, up at the very, very top, student 1 walks 3 feet per second, right? Our time is in second. So for every 0 seconds, 0 feet is walked. For every 1 second, 3 feet is walked. For every 2 seconds, 6 feet is walked. Do you see what I'm doing here? 1 times 3 is 3. 2 times 3 is 6. 3 times 3, is 9. Times 3 is 12. Times 3 is 15. So we can literally say that T times 3, I didn't mean to do that, will equal D, right? No matter what T is, T times 3 will always equal D, or 3T equals D. So let's write that down here where it says write an equation. So we would say 3T equals D. Okay, let's go on to student 2. Now this one, for every 1 second, he walked 5 feet, right? So times 5, 0 times 5 is 0 times 5, or 5 is 2 times 5 is 10. You're right, 15, 20, 25. And we can say that here, T times 5 is D. So let's go ahead and write that on our equation for student 2, right? We're going to put this down here. So now 5T is equal to D. See how we can change this variable here? This will change. These ones, however, will not. These are our dependent or independent variables. That was a bad choice. I'm going to use a different marker. Ran out of room. Independent, dependent. Whereas these guys are our dependent variables because they change. They're depending on something different. They depend on the coefficient, right? Okay, let's move on. So how is each student's walking rate related to the equation? How is each student's walking rate related to the equation? Well, that relates to the coefficient, right? Like I just said. The walking rate is the coefficient of t. So I'm going to say walking rate, I'm going to put this in purple, walking rate is equal to the coefficient of t. Sorry, I know my handwriting is a little sloppy. It's just because I'm lazy. No, this is just really difficult to write on. Let me just make it more legible for you. I apologize. Okay, so the coefficient of t. So remember, I'm going to do this in a different color. Maybe this will get confusing. The orange will be the coefficient. So this is the coefficient, right? 3 and 5 is the coefficient of t in both equations. Okay. Okay, so let's move on to the next section, graphs for constant speed. On the grids on the next page, graph the data in the tables from exercise 2. So let's go do that real quick and we'll come back up to this section. So remember, for every, let's do this one in, what did we do, student 1 in blue or green? Green. Okay. So for every 1 second, so we start with 0, 0, right? Right here. Then for 1 second, they walked 3 feet. And remember, this is the feet walked here, total time elapsed here. So we have t on our x-axis, and we have distance. I think it shows distance up here. Yep, distance on our y-axis. Right? Okay. So here we go. For every 1 second, 3 feet is walked. For every 2 seconds, 6 feet is walked. Then 9 for 3 seconds, and 12 for 4, 15 for 5. And it just makes this straight line all the way through, right? And we can graph it like that. Same for student number 2, who walked 5 feet for every 1 second. 5, 10, 15, 20, and so on. It's going to look like that. Continuing on up. Why am I drawing an arrow that continues on? Well, because I can do it for as many seconds as I want. The distance will remain the same. That's not correct. Oof. Went too far. It's got to go through that 0, 0 axis. My line is not perfect, but that's okay. You get the idea, right? For every 1 second, 5 feet is walked. For student 1, for every 1 second, 3 feet is walked. Okay, now let's go back up to this section. Does it make sense to connect the points on the graph? Yeah, it does. So we did. We connected them. Draw 2 unit right triangles in each graph. So I'm going to do this one in purple. It wants us to do this rise over run. Have we talked about rise over run? I think we did in challenge math in Agile Minds. This is called rise over run, and oops, that one's not pretty. Looks like this. So I go over 1 and up 5, over 1, up 5. Over here I went over 1, up 3, over 1, up 3, right? So how is each student's walking rate related to the graph? Go ahead and try to write that one in yourself. I'll give you a couple seconds. Go ahead and push pause on your video. Okay, welcome back. So let's go ahead and write this in purple. I need to zoom in on this so I can get an accurate. That looks like a lowercase t when it was not intended to be. Okay. The walking rate, I'm going to do this in my best handwriting possible. It's really hard for me to write on this screen. The walking rate, whoops, is the length of the vertical side. Vertical means this way. On the vertical side of a unit rate triangle. And that's it. So the walking rate is the length of the vertical side of a unit rate triangle. Okay, let's move on to the next page. Okay, so this says, suppose student 3 walks at a constant rate of 4 feet. Now we're adding in another one. So complete the table at the right. And, well, actually 6, we need to do number 6 first. Label this double number line for student 3. It should be pretty straightforward. We're going for every 1 second. How far are we traveling? We're traveling 4 feet. So there's 4, 8, 12, 16. Right? So I know that at 4 seconds, I will have traveled 16 feet if I am student number 3. Okay, let's go ahead and complete this table. So this would be 0. Oh, nope. I'm walking at 4 per second. So 4, 8, 12, 16. 4 times 5 is 20. So that would be t times 4 is equal to d, or 4t, right? Because these are the same. These numbers are the same, is d. Okay. So now we have an equation. Write an equation. Well, that was pretty simple. We just did that. 4d equals t. Which one is my independent variable? My independent variable, the one that does not change, that would be my t, right? I'm going to write independent. And that would make this guy my independent. Let me change that real quick. Dependent. Okey-doke. Okay. So now, number 9, Seth and Kinsey want to know how far student 3 will have walked in 2.5 seconds. Seth says he can use a double number line to find the distance. Explain how he might do this. So it's actually asking us to put in words how we would do that on a double number line. Well, let's draw the double number line first. So the double number line would look like this, right? And so for student 3, we're traveling, the equation is 4d equals t. So I know that for every second, I'm going 4 times the distance, right? Oops, I'm sorry. I did that all wrong. Let me re-explain that. D is equal to 4t. So for every second, let me make sure I wrote this correctly. Yeah, I did that. Nope. Did not do that correctly. I'm sorry, guys. I mixed something up here. Let's erase all of this. Sorry, it's just like in class, right? I made a mistake. Gotta go back and I gotta fix it. It's okay to make mistakes. as long as you go back and you fix them. So let's rewrite that. Distance is my independent variable because it is not changing. However, this is changing. Let me make sure I did that on all of my other ones as well, where D is the independent variable. Yep, I did it right up there. Okay, sorry, thanks for bearing with me. I appreciate it. Okay, so let's relabel these. These are my independent variables, or dependent. And these are my independent, because it's not changing. Independent. I'm going to highlight it with orange, and I'm going to highlight this one with magenta or purple so that we can tell that's how it is. Okay, now that we fixed that, I'm going to go back here. So for 0 seconds, I'm going to have seconds down here, and I'm going to have distance up here. Would it matter? No, but it makes more sense the distance would be on top for me. So I have 1, 2, 3, 4, 5 seconds, and up here I have 4 feet, 4 feet, or 8 feet. I'm having a tough time, aren't I? 8, 12, 16, and 20. These are all feet. Okay. So here's my rate. 1 second, 2 seconds, 3 seconds. So they're asking, how do I go to 2.5? How many steps will I have taken in 2.5 seconds? Well, I'm actually going to go back through here, and I'm just going to mark with green. These are all my halfway points. This would be a half. This would be 1.5. This would be 2.5, right? Okay, so there I am. So it's asking me to explain with words, and I'm going to do this in green, that I would put a line in between I would put a line in between each whole number to represent a half. Right? Okay. So Kinsey says she can use the equation to find the distance. Explain how she might do that. So I actually would just write, I would just put plug and chug. We're just going to plug this in and we're going to chug along. We're just going to solve it. So I would just put in, I would write in 2.5 or 2.5, whatever you're most comfortable with, to substitute for the variable D. Nope, T. I'm sorry, I'm getting those mixed up. 2.5 seconds for t because t is time, right? So you would just plug in 2.5 for the equation. So if I look over here, I would write d distance, how far did they walk? That's what I'm solving for. How far did they walk in 4 times the time, which is 2.5. Oops. And then I would just solve that. Well, 4 times 2.5 is 10. And I know that because 4.0 times 2.5, 0, 20 is 0, 8, 0, 0, 10. Move my decimal over twice. I'm left with 10, right? And same as up here on the number line, here's 1, 2, and a half. This is where I need to get to. What's half between 8 and 12? 8, 9, 10. 10 is where I would be at. So I can do it on a number line. I can do it on an equation. And so when I say I would just plug in 2.5 for t, my original equation here was this, right? Okay. Moving on. So calculate how far student 3 walks in the given length of time. Okay, so if we're using the same equation, I'm going to write that down here. I'm going to write distance is equal to 4 times t. Well, I would just plug in 3.25 for t. 3.25 times 4, let's do 4 over 1, times 3.25 is the same thing as 4 times 3, which is 12 plus 1 is 13, right? Over 4. That gives me 4 times 13 is, 4 times 10 is 40, plus 3 times 4 is 12. 40 plus 12 is 52 over 4. Simplified, how many times does 4 go into 52? It goes in, 13. Hold on. This is hard mental math for me, so I'm going to write it out. 4 goes into 5 one time. I'm left with 1. I bring down the 2. 4 goes into 2. Ooh, 3 times. I was right. 13. So the correct answer would be 13. 13 what? 13 feet. Sorry. We're solving for distance, and distance is in feet. It's really important to remember that. Okay, moving on, 2 5/8. I would do the exact same thing. D is equal to 4 times 2 5/8. Man, what is with these long numbers? This is going to take us forever. 8 times 2 is 16, plus 5 is 21 over 8, times 4 over 1 equals 4 times 21 is 84. And I know that because 4 times 1 is 4. 4 times 2 is 8. Over 1 times 8 is 8. That's supposed to be an 8. Simplified is, well, let's just do 84 divided by 8. 8 goes into 8 one time. Left with 4. 5 goes into 8 40 times, just like that. So my answer is 1.5. Feet. Okay. Good. Okay. I'm going to stop there for today. I will finish this lesson tomorrow. I think that that's a lot right now. Go ahead and start practicing this part on your homework. It's only the first part. go ahead and start doing that. If you have any questions, go ahead and shoot me an email or a message on Teams. I know that this is confusing. When Ms. Williams and I talked about doing this lesson, we decided that we were only going to do half of this lesson because it's tough. It's even hard for her and I when we start to talk about independent and dependent variables, and I know that you just saw that in this lesson. I myself got this confused, and I've been working with this for years, so I know that this is confusing. So I expect that you will ask questions, or you will rewind this video and you'll watch it again. I don't think that anybody is going to be able to just watch this video one time and just get it. So spend some time with it, practice the numbers. It's really, really important. This is the same thing I would tell you to do in class, right? Okay, I'll talk to you guys soon.